Go.
Okay, so we have our standpipe kit. It's our Stanford bag. It's how we have ours set up, pretty much the same. There might be some small variations. So we have this bag with the shoulder straps and the carry handles. Okay, so you throw it over your shoulder, you can carry it. So some of the parts that will be in the bag. Okay, nozzle, it will be on the hose. Although some departments do keep a spare nozzle in the bag, because I can explain that real quickly. If you have a bad nozzle, or you break a nozzle, or something happens, you don't want to be put out of service because of a bad nozzle. Some departments, some companies keep a spare nozzle in the bag. We don't, as policy here. So this will be pre-attached to the working length of the 2-inch hose bundles. So I'll just stand that off to the side. So let's get right down from where we're starting, coming off of the standpipe itself. So ordinarily, what we're going to do is we're going to put a gate valve. Now this is a regular 2.5-inch single gate. There's basically two types out there. There's the silver one, which is a co-check, and then there's the red one, which is the L-card valve, and there might be other variations in there. It's a single gate. What's important is that you count the amount of turns, so you have an idea. We'll go through that when we talk about actually dialing in the pressure. This particular one is 8 turns, so it's about 8 turns to close. 1, 2, 3, 4, 5, 6, 7, 8. So that's about 8. The L carts are a little bit more. I think they're 12, but it's just something that we know. The reason for this is so we can actually easily dial in the pressure off of the angle valve or the standpipe valve that's attached to the building equipment. Some of these valves they could be decades old. They can be 50, 60 years old. Some of them are hard to open. Some of them are very tough to move. And this allows us an easy way of getting the pressures where we want them to be. So that's why we carry it, is actually as to adjust our pressures. Some departments don't carry it. Some departments do everything with the standpipe valve. But this is a more efficient way. So this will be on that angle valve over there. We'll demonstrate the hookup in a second. We also have a 2.5-inch gauge, a lightweight gauge. If you don't have a lightweight gauge in your bag, put your request in through the deputy chiefs to the shops, because we're replacing the heavier ones. This is what we're buying now. This is our gauge setup now. It's very lightweight. It's got a big gauge, as you can see, because we have to dial these pressures in, relatively precise. So this would actually go on, and you always want to make sure this is going on after your gate valve. If you put this on right to the angle valve, then you have to always adjust with the valve, which is what we're trying to avoid. So this has to be downflow, downstream of your single gate. Okay, we'll demonstrate it in a second. It has this protective cap on it, so we don't break the gauge glass. The elbow. So we understand what the elbow is for. Now the elbow, it actually is two things. It's a drain elbow, so it has a drain bleeder on it. It has a purpose. But the elbow itself, the idea of an elbow, is that it actually changes the geometry of the valve. So I'm going to walk over here and I'll just talk about it for a second. Right now, I would probably put my gate right here, okay? And then I would probably put my gauge, and then to avoid maybe a kink, if this was low to the floor, I could put this on and it would straighten out the hose. Now, my reducer on here straighten out the hose. But if I were in a cabinet, and a lot of times these are in a standpipe hallway cabinet, or sometimes the cabinets are in the stairway. They're tight in there, and a lot of times it's a little difficult making these connections. Sometimes it's nearly impossible. This will change once again, my geometry, and get this so I can move this wherever I want. And now I'm not trying to work this inside of a cabinet where I don't have a lot of room. The bleeder is here. If we had now this has happened. Line gets charged and it's jammed under a door, or it's closed, stuck in a door, or it gets down between the floor plate and the well hole in the stairway, and it gets sucked in there. Someone pulls on or tries to straighten the line, and it's clamped in there, and now you put water in the line. You put water in the line, you're not getting water to the nozzle, which you want to do, and you really can't take these apart because it's charged. So it could be charged with a very high static pressure, even though you shut the valve off. Without a bleeder on it, you have to try to unscrew it and, relieve the pressure. So that does happen. You have a way of relieving the pressure. That's why we carry it. We carry it for changing the direction or geometry of the valve, or to get us out of a tight spot, and also allows us to have the bleed. So that's some of the functions of the tools that we have. And then we have a reducer, which takes us from our 2.5, our standpipe equipment, building equipment. On most standpipes today they have a reducer on there. We usually remove it if we can. Is usually 2.5 national standard thread coming out of the valve. This gets us from 2.5 to 1.5 inch regular threads for our hose. Our hose has 1.5 inch threads on it, even though it's 2-inch hose. In addition, we have a fog tip. So this fog tip is, we want to ventilate an area after the fire is knocked down. You can put this fog spray tip on it, and it's a 75 GPM. So it's a relatively has a decent flow to it, and allow us to ventilate the area after the fires are knocked down. And all it would simply be is removing our 7/8 tip and going back to the shut off valve after the fire's knocked down. Just put this on, and now we have the ability to put a fog stream on there, and we can ventilate the area after the fire's knocked down. Okay, so we're going to go through the actually setting up off of the standpipe valve. So we would be in a stairway, or possibly on a corridor on the floor below, because our hookup is primarily on the floor below the fire. So we'll go through. I'm going to have Nick go through the procedure. Now we take a look at this valve and we see what it is. It's got a cap on it. So we'll first thing we would do is make sure the valve is off. Just sometimes there's pressure on. Okay, take the cap off. It's a plastic cap. Came off easy. Cap may be difficult. We actually might need forcible entry tools to take the cap off. In this case, it came off easy, but we also have our wrench. We want to make sure there's not a pressure restrictor device in here. Some of them look like another couple. You just take them off. There could be something in there. So he's going to actually probe that with the back of the standpipe. Take a look in there. And it's a regular angle valve. It's not a pressure reducing valve. It's a straight angle valve. And, it's our standard valve. So we're going to dress this out like we would. Now, when do you flush the standpipe valve? It's a question. So what I would do in this case, Nick's going to do it. We're going to put our gate valve on there. He's going to hook it right onto there. And he's trying to work his way away from this valve so they don't interfere. And under ideal conditions, this is pretty good. This is pretty easy. We have room to work. We're not constricted to a cabinet. He was able to reach around and back here and get his fingers around it to turn it. But sometimes these things are really in a tight spot, and you might have to use your elbow. So if we had put the elbow on this, it would get us out of the cabinet, and we can now put the gate valve on the elbow. But in this case, we did okay. So what we want to do at this point is, this is when we want to actually do our flush. Reason being is, if I get this valve open one time, I don't want to have to mess with this again. This could be some real old corroded valve. I got control here now. And this is the point, guys, sometimes confused. I got to flush this, but I only want to open this valve once. So what I'm going to do is, what Nick is going to do, he's going to make sure this is shut. Okay, so it's shut off. Okay, now he's going to open that. And this one opens easy because it's a brand new valve. But he may have to struggle with that. He may have to grab a Halligan. He might have to grab his pipe wrench. We don't have a pipe wrench in the bag. And hook his pipe wrench in here to help get this thing started. This may break off and may have to operate on grabbing the stem. There's a whole bunch of techniques of getting these valves over. But now it's wide open, and I have control here. So this is where I probably want to flush. I don't want to put my gauge on it right away because I don't want to put a piece of rust or some sort of gunk inside of my gauge and plug up that little orifice in there. So now would be a time to flush. And he would open that up, just open it up, and it would be cleared out. So he would clear it out. And he's content with that, he shuts it right off. Because here's another point. Water on the floor, it's water damage. Water on the floor, even though it's on the floor below, it gets into the elevator and gets down into the elevator controls, could shut down an elevator to high-rise buildings. And we have tall buildings in the city. So we would like to preserve the elevator as much as possible. So when we do our flushing, we don't want to create a tidal wave that it finds its way into the elevator shaft. If you're in a stairway, not so bad. The water's just going to cascade down the stairway. If you're in a corridor, a hallway on the floor below, that water could find its way into the elevator shaft and shut down our elevators. Just a point to remember. So now we have our control here. We flushed our valve out. Let's put our gauge on there. So now we can face that gauge so we can see it. Another option would be to put now we could use our elbow to maybe a little better advantage. So why don't you take that off and just put it right on there and put your gauge out so you can see it easier. It's just another option. Yeah. I don't have a big rule on this one. It doesn't really matter that much. Put your gauge down here if you want, if it makes life a little easier. Now we'll put our gauge on. Okay, and put our reducer on. Now this reducer is a swivel reducer. It will swivel. You could actually have this pre-connected to a length of hose, and it's not a solid connection. So that's a way of doing it. The one point that is a critical point to remember out of what we just did here in the last minute of hooking up. You don't want to put your gauge upstream of your shutoff. Okay, then you have no control by means of the reason we're putting this on here so we can actually control the pressure. So this is done correctly, whether we put the elbow in or don't put the elbow in, it's not that important. It may have some importance, but not a lot. The thing that's important is that you don't have this gauge up in here. If you have it up in here, then you have to do everything with this. And this could be a very difficult thing to try to do. The handle may break off. And now we're messing around trying to do it with a pipe wrench or pliers or something like that. So once we get this open, we don't have to worry about it. We have all our control from here. So this case is set up correctly. The hose goes over here, and we're ready to go.